Hi everyone, so this is Emmy, and I'm here to talk a bit about the Project 2 firmware. So, not a lot's changed in terms of the functionality, but as you might be able to tell already, there's this giant array which takes up around 300 lines, so most of the program is taken up by this array. And so this is actually the neural data. We're encoding it as a short, so that's a 2-byte number. And so these take on values from 0 to, I believe, 65,556, I believe, or 536. It's somewhere around there. I don't remember exactly. It's 1 to 2 to the... It goes from 0 to 2 to the 16 minus 1. In any case, we can kind of mostly ignore this. That's not really all that important how this works. But I do want to talk a bit about the functionality from Project 1 that has had a few updates. So we had a few patches for functionality that happened in Project 1. So we noticed that a lot of people weren't really sure what was going on in the case like certain situations would happen. Like if you sent a bad packet type, the Arduino would kind of just ignore it. Or if you sent a bad opcode, it would just ignore it. If you try to connect when you're already connected, the Arduino would kind of ignore that. So a lot of these situations in the past, the Arduino would kind of just ignore. But really, you're not supposed to be doing any of those things. So like if you're trying to connect when you're already connected, you really that's not allowed. So what we'll do in the new firmware is actually we'll send out error codes for them. So they're just using the same failure packets that we were using last time, but this time we just have a few more error codes. So you can count them a new one. So we have from 2 to 7. These are the new ones. So we have we have 6 new ones, and you can kind of see them emitted right here if we go down to these init connections. So we have a new function called send error packet, that just sends out an error packet with the specified error code. And what we'll do here is we'll just kind of check various conditions to see if you meet the error conditions, and the transactional commands will terminate with a failure in that case. So you can see here a lot of the new commands do require that you be connected before you start them, so you can't just connect your Arduino and send like a start streaming command. You do have to send the connect command first, which you all should do and have since we gave you the Project 1 checkpoint. Or if you're continuing off from your code, you can, and you should already be doing this anyways. But this is just for your debugging purposes, really. Like ideally in a good API, none of these should be actually happening. So this is just for debugging. One more additional thing that's happening down here in the serial event function is this this return wasn't here before, and so the reason we put this in was because this serial event function will kind of continue as long as there's data in the serial port, but something I realized was if there's multiple packets in the serial port, it'll kind of read them both in at once, so that you actually only get the last packet. So it'll kind of read through the entire first packet, set this to be true, but then there's more data, so it just starts again. And so at that point, it just kind of gets stuck in here. So we don't want that to happen. So we put that return early. We put this return here so that it processes each of the packets one at a time. So that was just a minor bug. I don't think anyone ran into that, but we did fix that in this patch. All right. Now let's talk a bit about the streaming. So there's 2 new commands that you kind of might have already seen, which is start and stop streaming. And so when you start streaming, what will happen is the Arduino will start iterating through that giant list of neural data right here. It'll just kind of start spitting out each of these values. And so if we go to the streaming, or if we go to loop, which is down here, you can see that we have this new block right here, which happens if we're streaming. So you can set this to be true using the start streaming command, and what it'll do is it'll record the current time in microseconds and kind of check the elapsed time. If the elapsed time is more than the stream period, which is 2,000 microseconds or 2 milliseconds, so that's like a stream frequency of 500 hertz, we'll send out a new packet. So this just times it so that we're sending out a packet every 2 milliseconds. All right, so at this point we'll record the time. So the timestamp is just the current time in milliseconds. and this is a 4-byte value, and then we take a sample from the Arduino's flash memory. So we'll just take one sample, and we'll copy those into the stream buffer, and we'll send it out like so. In this case, we also increment the index. So the index isn't actually incrementing when you're not streaming. So it's kind of like a play, stop, and start sort of thing. So you can start playing the stream data, or you can start playing the neural recording with start streaming, and when you stop streaming, it kind of pauses it, and when you start, it'll kind of resume it. So and it'll wrap around, so it'll just kind of play on repeat. It's just on a loop, and so this just what this does is it'll increment the index by 1 and wrap around if it goes to the end. And then we record the last time, and we'll wait again and spit out another packet. So that's really all there is to the stream data. Now I wanted to give you a couple tips for working with the code when you're actually making this application. So give me 1 second. I'm going to restart my Arduino, and I have the code pulled up right here. And so I'm just going to run this. And what you should see is you should see is once we start streaming, and so we're going to try to connect real quick. It's attempting, and now we're connected. So you should emit this message. So this time you'll have a few different commands. We have A to start streaming, and B to stop streaming, and Q to quit. And so I'm just going to start streaming real quick, and you should see a bunch of data being received, and this is just a lot of data. And so this is actually really hard to determine if we're actually recording it right. I'm going to stop it real quick. One thing that you could do is you could look at the log files. And so I'm just going to open up my File Explorer real quick and go to where I have the project files stored. And so when you are actually logging this data, when you open a file, this is kind of where it's going to be saved. So in your application, go to bin, go to debug.net6, and this is kind of where it's all saved. So when you open a file, the default directory it's saved in is where your program runs, and this is kind of where your application.exe is. So when you start your program, this is actually where it's running from. And so it's in bin debug net6, and these are all the stream files that I have. And so it'll close the file after you're done with the application, assuming you close the file at the end. Make sure to do that, or else it's not going to save. And so you can see various files that I have of the neural data. So this is one, and you can kind of compare this to the neural data that we have in this giant array here. And so what you should do is you should compare these two. So let me pull up one. I think this more recent one. I think these are older recordings, but in any case, you should match. These should match up 1-to-1, and it'll just start streaming from the start. So just kind of look at the first two values. Another way to kind of compare the values is to go up here, and so I'm just going to close the program real quick. And so we can actually change this stream period. So for your own testing, you can change this. And so this is at 2 milliseconds, but I can actually change it to, I believe, half a second. So half a second is 500,000 microseconds. And so this is just 500,000 microseconds. And so now the stream is significantly slower. And I'm just going to upload this to the Arduino. And it's uploading. It's kind of a large file, so this time the uploading should take a lot longer because we're also writing this giant array. So now that's written, we should see when we start streaming, the data starts coming in a lot slower, and now we can actually read it, as you can see. And as you can see, also, the data matches up kind of exactly if let me pause the app, or let me stop streaming. But if you look up, you can kind of see that the data matches the ordering of these little shorts right here, and that's what you should get. So these match up, and that's what you want. So that's one way of determining whether your behavior is correct. The other way is just to look at the log file, but I think this is quicker, so you don't have to like constantly open a file. You can just kind of print it out to the screen. All right, great. One more thing that I want to talk about. So I'm just going to change this back to what its original value was. And so if you go in here, you'll see that I'm printing out the timestamp in milliseconds. So something I was doing, something that you can do, is you can actually print out the timestamp in seconds instead. And the way you would do this is multiply it by 0.001, and I'll print it out as a float. And so this just makes it a float value, or as another word for it would be a single, which is half the length of a double. So this is a 32-bit floating point representation. And so I'm going to reset my Arduino real quick, and I'm going to start the application again. And so when I start the application again, it's going to try to connect. And now we'll see it streaming these floating point numbers, which is great. And you can see it streaming every half a second, and which is also good. Actually, I forgot to re-upload, but that's fine. We can just re-upload right now. So I'm going to re-upload this code with the old streaming period, and it should be a lot faster now. Okay, I'm going to run this now, and you'll see it kind of stutter, actually. And okay, so what happened? So the Watchdog service seems to have timed out, and so let's think a bit about. I'm going to pause the program. Well, why did this happen? So you'll see the Watchdog times out 3 times, but like, how could that happen? Because it wasn't timing out before, right? And so the only thing that we changed was we, instead of printing out an integer, we're printing out this floating point number. And it turns out that printing out a floating point number is actually very computationally expensive. And so this is just something that appeared in my testing. So one way to think about this is converting a floating point number to a string actually is quite difficult for a computer. It's a lot more complicated than you think, because you don't know how many digits you have in there. You could be converting a lot of digits, and the process is just a lot harder than converting just a raw integer. And so, because floating point is just very complicated on a computer, especially this. So this allocates actually a new string. So the one way to think about this is we actually have to, this string actually takes up a certain number of bytes in memory. And this string, we don't know its contents ahead of time, right? We don't know what this is going to be, and we don't know what this is going to be. This is kind of like fill in the blanks, but we don't know how many bytes this string is going to be. And so what will happen every time this function gets called is C# will actually create a new string, a completely new string that's completely different from all the previous strings. So it's going to allocate maybe I don't know, 30 bytes for this string, and then print it out. But then we just throw it away immediately. And especially converting this is also very intensive. So we're kind of doing 2 very intensive operations. We're converting a float to a string, and then we're allocating a new string every single loop cycle. We're receiving the data at 500 hertz, so we're allocating a string every 2 milliseconds. And this turns out to make the program spend a long time in this thread. And this thread's just kind of eat up all the resources of our processor, right? So when you multi-thread, your processor is kind of multitasking, but it can only do so many things at once. So if you have a 2-core processor with 4 virtual cores, it can kind of run four threads at once. And when we're doing all of this, your processor is going to have to something's got to give, because it can't do everything at once. This one thread is asking too much of it, and so what will start to happen is that this thread will kind of eat up all the computational resources of the processor, and it's not going to have time to run the Watchdog thread. And so we call this starving the thread, actually. So this is just a warning if you're trying to print out a float, that you shouldn't be printing it out so often, because if you print out a float really often, what will happen is that your Watchdog thread will get starved and your Arduino will reset itself, because the Watchdog isn't being sent often enough, or isn't being received often enough. So something you can do to fix this is just to not print out a float, just print out the integer timestamp in milliseconds. So yeah, that was just one caveat that I wanted to talk about that appeared in my testing. Hopefully this helps you debug your program and answers some of the questions that you have. Obviously there's more code than this. I didn't want to show the actual solution. I just wanted to show like printing it out and this one little caveat. Well, that's all for Project 2 firmware. I'll be seeing you guys again in Project 4. Project 3 will be handled by our postdoc teaching assistant, Ares. And good luck. I hope you guys have fun with Project 2. I know it's a lot more intense than Project 1, but as always, me and Cory will be open during our office hours.